Assalamualaikum warahmatullahi wabarakatuh. Our respect lecturer Miss Yuriska Mulyasari of STEM Education course. Introduction, we are from Group 8 with me, Umi Mar'atus S with the last three digit of name 031. And my friends, Alkhikmatul R with the last three digit of name 237. And my friends, Dwi A with the last three digit of name 270. On this discussion, we will present the result of the science STEM learning assessment and student worksheet or learner's worksheet. Okay, in learning assessment design, assessment objective. This assessment evaluates student ability to identify real-world transportation problem, apply the coordinate system, integrate STEM element, work in teams, and present data-driven argument. So the engineering concept is rail track design, geometry, Cartesian coordinate system, and distinguish formula between 2 point, and scale, distance comparison, and the STEM integration, science, fluid zones, population destiny, environment, and technology is use of GeoGebra and Google Maps, engineering, rail track design, and mathematics, Cartesian coordinate, design, calculate, and scale. So the content integration is solution-centric. And the aspect of SDGs is SDGs 9, infrastructure and innovation using data, SDGs 11, sustainable city planning, and SDGs 13, reduction emission through public transportation. So the project uses project-based learning with the engineering design process. This is the best LH as follows: 1 until 7, this. And the assessment format and produce type, group project and presentation, duration 3 meetings, output, project report and presentation, documentation, every pass must be recorded. So in infrastructure for conducting the assessment, goals to expectedly result, assessment objective this, and expect learning outcome this. So the required tool and materials, plywood, duplicate paper, remote control car or train, wood, glue, accessories, fluid plan map, and stopwatch. So in implementation assessment, 1 is introduction and discuss, teacher introduce city station problem, student discuss factor of affecting, assessment, participation, and logic response, and 2 planning, collect the data, school, market, and each other, and then calculate distance using coordinate system, and divide us and prepare materials. And the assessment is planning quality and initial data. So in part 3 is product manufacturing, product creation, build station layout miniature, visualize road using GeoGebra, assessment, assurance and clarity of output, and the part 4, testing and primary presentation, test distance and location efficiency, present initial findings, and the assessment is use of data in justification. So in part 5, reflection and import, present and reflection analysis, receive feedback, receive the product and reflection on process, and the assessment is depth of reflection and revision.
So in here is my teaching module are coordinate system. So this SDGs is number 9, 11, and 13, which is industry innovation and infrastructure, and sustainable cities and communities, also climate action. So about the lesson title is transportation route optimization with coordinate system. So the topic is efficiency and the coordinate system. So this level is junior high school for grade 8. And time location, session 1 is 80 minutes, session 2 is 80 minutes. So and the session 3 is not titled yet. So next, in here, teaching approach is solution-centric by model project-based learning. So in here is the student will be investigation, discussion, and problem solving. So the problem is how to determine the best transportation route to make your trip more cost and time efficient. So in here, learning model is PCBL for project-based learning, and because it's relevant for this topic. So okay, next. So the main problem is energy efficiency for the public transportation system, and additionally design and placement of transportation for station. And learning outcome, it will be for engineering, the student will be create other city design and build a prototype. In mathematics, student will be measure distance and time accurately and use speed formulas to calculate the movement of the cable car or train. In the technology, in here, student will be use the GeoGebra to visualize and design the miniature. In activity objective will be in mathematics, can understand and Cartesian coordinate and measure and calculate the distance and analyze time and speed. So also design mass coordinate system by using GeoGebra. In engineering objective will be the design and construct functional table train using trial and error to improve their project. In here is integrated learning. It will be in science to observe phenomenon, but people need transportation. Number 2 is environmental understanding to transformation accessibility needs. In technology, we'll use like before GeoGebra and create digital presentation. In engineering, will be design and strategic location, considering design efficiency and testing and proving the initial design best for of the group analysis. In mathematics, it will be determine coordinate point, use the design formula, and analyze pattern and make decision based on mathematical calculation. Next is will be solution centric. In here is or number one is initial solution presentation. So at this stage, the student it will be explained there for their understanding of the problem and present a solution of their plan about cable train system. Next is solution exploration and adaptation. Student will be deeper into initial cable train system design by exploring ideas and making meaningful assessment. So in here it will be like before is like their idea is other safety or what it is. So next is reflection on the solution. In here, students reflect on the design journey, including the challenges they face and improvement they made and how they apply concept from SDA. So next is justification and transformation of concept. This phase it will be just like theory and practice. So it help the from developing and develop ability to communicate listening logically. So in here is this just testing and reflect how their knowledge contribution. Next is this is EQP or engineering design process. In here is by PCPL syntax stage. So in number one is ask. So like before to the learner's worksheet. So in here will be additionally by worksheet as summative scoring. In worksheet it will be at problem identification section. So the student it will be introduce the transportation efficiency and function system. So there will be discussion and show example for problem solution and ask the teacher to analyze the solution. Next is research. In this stage will be concept exploration for the student, how they can explore information like school, hospital, or place is the place of significant by the city. So next is imagine. Here student will be imagine more route optimization with coordinate system. They will be create their ideas in here. Next is a plan. So after imagine there will be make decision in the plan. So in here student will plan the material they need and create a design by using GeoGebra application. Next is create. In here for the GeoGebra it will be student will be make a miniature with they choose location point by their reason for choosing the location. Next is a test. Student in here will be test their product by the guideline provide condition in the worksheet, so they can test and evaluate their project. Next is improve. In here, student will improve the product they previously get by making revision based on the result and feedback from their friend and the teacher. Next is solution-centered approach or next is project-based learning. This is different like before. Before is syntax by ETP and here with PCPL. So in number one is start with the essential question. And here student will be respond to the teacher question about the route optimization from the cable tray. Now in here this is also like ask in stage of ETP where the student explore every aspect of the solution. Next is design a plan for the project. Student develop the solution from question into work plan. They will be in research and imagine in like in ETP. Next is create schedule. In here student will make a plan, create and test designs of each step in like ETP. Next is monitor the student and the progress of the project. In here, teacher will be the monitor the student progress of their project, discuss about their progress, and resolve their struggle in the project. Okay, next is assess the outcome. Student will test the design miniature project in GeoGebra. And next it will be evaluate the experience, student improve their product, and reflect from while learning process. So they will be discuss about this learning. Next is in here project general description. This is similar like before. From this like main problems is same and also activity objective. So in here tools and materials. Number one is plywood or two-text paper. Number two is remote control car or train. Number two, next is paper board, glue, scissor, floor plan map, and stopwatch. So in the lesson timeline it will be like stage of ATP before. So in meeting one it will be ask, research, imagine, and plan. And meeting two is will be create, test, and improve. Also in meeting three just presentation and evaluate. So in here for the testing guide. So in testing guide, there aspect will be tests like stability and neatness of miniature track, train travel test, accuracy of station location, travel time efficiency, map conformity to miniature, presentation, and visualization quality. So this is a applet GeoGebra we can make. So you can try this applet GeoGebra.
Okay guys, here I will explain about STEM Integrated Summative Student Worksheet. Project name is Smart Mayor Strategy Location of City Station for Class 8. And then working instruction 1 from group of 4 until 5 people. 2. Assign a group leader to lead the discussion and coordinate tasks. 3. Prepare stationary device to research for information and necessary equipment. 4. Read all parts of the student worksheet before working on it to understand the flow of activities from begin to end. So the first is problem identification. Here is a video of the problem. The students are asked to watch and discuss with their grade Then there are some equations. For example, why is public transformation important for a city? The point C here present a table of several sub-district and villages in Surabaya, such as Bubutan, Genteng, Gupeng, Sawahan, Simokerto, Tambak and Tegalsari. And then the students are asked to explain the reason based on consideration such as geographical location, population density, and mobility, ease of access from various places, and possible impacts on the surrounding area, such as social and economic impact. And the second is concept exploration. Here, students are asked to conduct a group discussion to answer the following question. You can use the internet, reference book, or digital maps, such as Google Maps and GeoGebra. For the first material is coordinate system concept and location efficiency. Then there are 6 equations, for example. 1. What is Cartesian coordinate system? 2. How to determine the position of a point on a map using coordinates. 3. Explain how the formula for the distance between 2 points is used to measure travel efficiency. And other. For the second material is urban planning and social understanding. Then there are 5 questions. For example, 1. Who will benefit if the station is placed in a strategic location? 2. Can public transformation, such as monorail trains, have reduced congestion and pollution? 3. Do you think it is better to build station in the city center or split them out in the suburb? And other. The third is designing and problem solving. Here, students are asked to design and solve a problem. The project Smart Mayor Strategy Location of City Station is a project-based learning activity that integrates science, technology, engineering, and mathematics, or STEM. In this project, you will design and determine 3 strategy points as the location of a train station in a city using the Cartesian coordinate system. There are tools and materials such as plywood board or duplex paper, remote control car or train, cardboard paper, glue, scissors, plan map, and stopwatch. And some questions, for example, 1. Why do you think we use cardboard to make train track? 2. Why are we using a city plan map in this project? What does it have to do with coordinate system and station location? And other. The 4 is create a product. In this project, you will determine 3 train station location using Cartesian coordinate and design a train router connection them. Using GeoGebra, you will analyze the distance and travel time and present the result. Here are the steps you need to follow. Step 1. Determine station location. 1. Select 3 station location point. 2. Mark the point in GeoGebra. 3. Site selection discussion. Discuss the reason for selection the station location with the group. Some factors to consider are accessibility to city center and residential area, distance between location point, population density around the location, and the last, potential other transportation route that can connect to the station. Step 2 is design the train route. 1. Designing a route in GeoGebra. 2. Calculating distance between points. 3. Analyzing travel time. Formula used, distance equal to speed multiplied time. Step 3 is making a miniature monorail trains. 1. Print out a floor plan map of the station you have chosen as your train route. 2. Attack the station location plan map the board using glue. 3. Make a track from cardboard or plywood that is the size of the remote control vehicle and follow the step of the track that has been designed in GeoGebra. 4. Test the track that you have made. 5. Calculate the transit time using the time calculator that you have provided. The 5 is trial and evaluation of the product. After completing this project, test the concept and evaluate the result with the evaluator or teacher. Then discuss and fill in the following reflection. Test step number 1 is stability and neatness of miniature track. And then test step such as check that the train track is neat and does not wobble when touched and walked on, and other. Test step number 2 is train travel test. And then test step such as run the remote control or toy train on the track, and other. Test type number 3 is accuracy of station location. And then test step such as compare the location of the selection station with important point of the city on the map. For example, market, school, settlement, and other. Test type number 4 is travel time efficiency. And then test steps such as measure the travel time from one station to another using a time calculator, and other. Test type number 5 is map conformity to miniature. And then test steps such as map the miniature to the city plan, does the layout on the track maps, the maps or coordinate visualization, and other. And the last test type number 6 is presentation and visualization quality. And then test steps such as are the digital maps or GeoGebra displayed clearly and legibly, and other.
Okay, in part C, revising the product, once you test the result and present your preliminary result is the time to reflection. You must do screenshot of the map GeoGebra display or new sketch that you revise. In this, your photo or sketch or GeoGebra, and this is revision details and revision reasons. And point G, summarize and communicate. So, this is what is not quite right about your product, what feedback did you get from your teacher or friends, what did you improve based of that feedback. In this section, you are asked to reflect and count your experience during this project. Okay, and then this is a formative assessment tool used to evaluate STEM-based project of covering all stage or project implementation. And then in point A, STEM project assessment, the rubric is divided into 7 project stages. Stage 1 as identifying problems and needs. This is science understanding transportation issue, engineering as critical question, recognizing in role of coordinate, collaboration, participant in discussion. And the stage 2 research, exploring concept, use of tool like GeoGebra, maps, city analyzing, comparison, location, teamwork. And point 3, stage 3, image and plane, designing solution, apply distant formula, sketching it digital visualization. And stage 4, build the products, scheduling, clear work step, effective teamwork. And the stage 5, testing the product, validation, coordinate, and design using digital tools. And the stage 6, improve product refinement, using data and calculation to improve and justify design. And the stage 7, presentation and evaluation, final reflection, discussing social or environmental impact, proposing improvements, team reflection. And the part B, score formula, final score equals to total score divided by maximum score multiples 100. And part C, assessment categories, 85 until 100 is very good, excellent result, strong argument, need visuals. And 70 until 84, good, minor flaws mostly well done. 55 until 69 is fire, basic understanding with planning. And under 55 is need improvement until clear STEM understanding. And the part D, score right set. A blank scoring set is providing to record each group performed by stage and criteria, making it easier for the teacher to calculate final score. This is calculate final score. And that's all. If there is any mistake, please apologies. Wassalamualaikum warahmatullahi wabarakatuh.